All right, so here we're looking at the Dark Ruins environment example from Megascans. We have a couple of really beautiful shots here, just going around the environments. I want to try and look at this project and see if we can find some obvious performance issues that we can improve on that will also apply to your projects, as they're just super common issues. Now, there's also some things that are just common issues with things like Megascans that we might look at, but generally speaking, I want to keep it broad enough that it should apply to your game as well, not just this particular example, but some things will be maybe a little bit sample or material specific. Now, I'm currently running this on a 4080 Super, so that's a pretty high-end GPU. Generally, this should already be running pretty well. I would say it doesn't like run super well, to be honest, but it looks absolutely beautiful. My goal is to try and run this in a package build on maybe something that's a little older. I have a 2080 Ti lying around that's used to be a high-end GPU, but now it's, you know, a few years old. Or even something as crazy as a Steam Deck, to see if we can scale this all the way down to something really low end. So there's one like small issue with getting this to run, and that is that it already relies on megalights. Now that's an experimental feature as a 5.5. And so if we just press G to get out of the game view mode, we can see that there's just this ridiculous number of lights here. Now, they're not all affecting this scene right now, because if we were to look at something like these candles, it's actually that only the highest one is affecting the world, and the other two are set to affect the world is off. Probably just some, you know, there's a non-destructive workflow, but it's a little bit misleading in the number of lights that are actually in the scene. We can check that out here. If I just select, they're actually called does not affect world, and we can also see that, yeah, affects world is disabled. So it's not as horrible as it makes it out to be, but it's still pretty awful in terms of the number of lights that we have here if you were to turn off something like megalights. And I don't really want to rely on megalights that much, because again, it's 5.5, it's experimental, you might not even be on 5.5. And I doubt you want to use a experimental feature in production. There's also some other issues that I noticed. Some are like specific to this project, so I'm not sure what's going on, but we can mostly work around those issues, luckily. So then a quick little rundown what I want to check out. First of all, light complexity, although that is a bit of a problem when there's just this many lights. I can show you the light complexity view, but this is just ridiculous because we have the light complexity here and it's just basically entirely white. Now, I think that's just because of the just mega number of lights that they placed here. And with megalights, it can sort of work. If we enable stats GPU, we can see that the megalights is currently at this editor viewport taking up 3 milliseconds or so. If we press F11, we can see now it's 6.6 milliseconds, so it's increasing quite a lot already. Now, this is not great. And also the number of lights, it really doesn't show in terms of quality, so to speak. So if we were to just view it from this angle, like this, we could really solve with just a couple of lights. We have, of course, a beautiful light falling in, and we have some other like fill lights here. Actually, I moved this mesh around. I should just delete this guy because there's this beautiful skeleton here, which a ridiculous amount of detail. Also has a couple of issues that we should fix. And of course, running this in the editor is not super great because we have like a very variable like screen percentage that we're using. Currently it's on 50%, and we are rendering this at 4K. So it's upscaled from about 1080. So that would actually be a reasonable target, by the way, rendering this internally at 1080p and upscaling this to 4K. And that's generally what Unreal Engine wants us to do if we're running something at 4K. I think generally it expects maybe a 1080p upscale or 1440p if we have the budget for that. But yeah, super project dependent, of course, and hardware dependent. So if we want to cover everything, I think it's going to be quite some hours of time to spend and dissecting this project. So we'll see how far we can get, but I just want to go through some of the options that we have available and some things that will be immediately relevant to your project as well. So the first thing I want to check out, because of course I've already seen some of the things in this project. So I've typed out set GPU to hide this again. And one thing I want to see is the virtual shadow mapping visualization. So we have the virtual shadow map, and then I'll go check out cached page. In 5.5, they updated the visualization mode, which is significantly easier to use than 5.4 or prior. Now, for some reason, this is a little bit bugged for, I don't know why in this particular sample. It works fine in other samples, but I'm only able to see this particular light here invalidating, and I can't get any of the other lights to invalidate for some reason. Now, this is the main light that I wanted to check out anyway. There will be other lights that are potentially issues that are invalidating as well, but at least they're all going to be the same step, so it doesn't really matter. Now, it took me a little while to understand where this light was coming from. Somewhere coming from above there, so we have this giant light casting some volumetric lights, and it looks really cool. But if we look here, we can actually see, okay, so this really must be the source of the light. It matches with the shape. Actually, what it's doing over here is just casting this light on the scene right here, and it's actually massive. If you look at maybe hopefully a view, no, this is not going to help much. It's not going to show us. There we if we go into some other geometry, that we can see just how large this cone is. It goes quite far. Let me just press F to go back to this light. Well, the thing is, there's a bit of an issue in terms of performance, because even though it's stationary, well, it's movable, but even though it's not moving, it's constantly invalidating. And we can see that by, if we go back into the cached pages view mode, by it being blue. So that's dynamically invalidated. So something is causing all of these pages, like literally every page, to invalidate every single frame. And it's quite a significant light as well. So there's a lot of pages, and this will be costly for us. And it's also not going to be the only light. Now, luckily, we have some other view modes available. Again, just press F to go back to the light. We can use some Nanite visualizations. So just go to Nanite visualization, and then I have evaluate WPO. And immediately I can see the problem, because all of these materials, all these meshes are set to green. Now, in this case, green is bad, because green means that the world position offset, the WPO, is being evaluated for these meshes. This sounds really unnecessary, especially with things like nanites. WPO is very expensive. You don't want it unless you really need it, and you only want it when you're nearby. Well, the problem is that there's no distances, like max distance set on evaluated WPO. This is something you can, for example, set when you have foliage that needs to animate with the wind or something like that. Then you have something like evaluate world position offset that you can toggle on and off. And you can see the toggling here, where it will stop evaluating that, and then it will switch to a faster render path for nanites, for those nanite meshes. Now, of course, I already did a quick look at the material to figure out what this could potentially be. And if we just step into this material, let me open that here. And we have the Smart Master that is something I'm assuming from Megascans. Now, here actually is where we can find the issue. It has some kind of material function, context shadows, and that is doing certain things. Also, it has pixel depth offset as a potential setting for the PDO, pixel depth offset shadows. Now, the problem here, I'm not sure why they're using this. I would have to look into this more deeply. But basically, the context shadows is something that they're enabling here on this material. And I'm sure it can look amazing in certain scenarios, and it probably has some really cool visual effects that we can get with it. But if the level is not set up properly for this, especially with something like these context shadows, as soon as you have that, you really need to properly manage your evaluation distances. And maybe if you get up really close to some kind of mesh, then you might want to have those context shadows because they might look amazing. I would have to look more deeply into that. But with no evaluation distance set, the problem is really that all your shadows and all of these lights are constantly going to be invalidating. Now, for some reason, I can only, in this particular scene, I can only get it to visualize that one particular light. I don't know why, but the other lights are also constantly invalidating certain pages. So long as if we just toggle to other places in the world, we can see that there's a lot of sections. All of them basically have a lot of green, and that's all bad. It's all of those rocks basically. So for now, without doing too much stuff, I'm just going to work around this issue by literally just bypassing this whole context shadows material function. A bit of a hack, obviously, but this is the fastest way to show this difference to you. And so we go back to evaluate WPO, and now everything is red. So this is awesome. This is a way better view. So we can just go between all of them. Let's see where we were actually. Somewhere here we can, we can fly back to that one particular light. Let's see. Let's go back. It was this light. And now if we go back and we check out the evaluate WPO, oh, we actually already did that. So that's good now. And now we can go back to virtual shadow map cached page. And we can see that, yes, now it is properly working again. And only when we go in and out do we see that it's invalidating individual pages because we're transitioning to a different resolution. And so before we continue with other stuff, I want to make sure that we get a quick before and after. So I will just use stat GPU. Now, of course, this is all in editor, but still it should be like a reasonable comparison. I'm going to make sure it's in full screen as much as possible. I'm going to toggle between having that WPO enabled and disabled by just recompiling those shaders at the moment. And so what we want to look for with this is especially shadow depth. So now we have shadow depth at 1 milliseconds, because that's really where the cost is going to be. So if I reapply and we have the original WPO again, so let's reapply that. It recompiled. Let's go back to lit mode. So now you can see that it's about 1.7 instead of 1.0. So in this particular scenario, with this particular light, we shaved off 0.7 milliseconds, which is, well, percentage-wise, quite a significant difference. And this is just with this one major light, but basically the entire scene would have been affected by these invalidations. But again, because of that bug, we can't really properly visualize that. But we do see a performance benefit of turning this off. And visually, I don't think we're going to really notice this. So I think this is certainly a surefire thing that we should just apply. I'm going to reapply without the custom context shadows nodes. And we are back to 1.0. Probably there's still other things that we could improve here with invalidation, but this is at least a pretty good start. So one thing I'm going to do before we move on to anything else, I'm going to just draw the virtual shadow map stats on screen. So I want to search for virtual, because everything is under virtual for shadow maps. Well, at least virtual shadow maps. Virtual show stats. So we have r.shadow.virtual.show stats. And now we can see that, okay, well, actually we don't really invalidate. We have dynamic cache 65 and static cache 65. So I don't see any invalidations happening. So at least I got that confirmed. And then if I just one more time reapply the original material, we can see that the dynamic cache is 0 and dynamic invalidated is 65. So it really flipped. All of them are none of them are dynamically cached anymore. So you can see that indeed helped quite a bit. And now it's all dynamic cached again. So that's great. Okay, we can just hide those stats again. If you, by the way, toggle this and you don't see these stats show up, even if you run that command, it is all under shader print. So if you have r.shader print, that should be set to 1. Because otherwise it might not render. So this, just in case it doesn't show up for you. Then let's hide this stat GPU for now. And also let's hide the virtual show stats. We don't need this anymore. Then let's move on to something else that you will very likely suffer from without realizing. And you can already see this happening over here, where if we wait a little bit, we have these particles that are just beautifully simulating in the world. And if we use shift plus / on the keyboard, it will forcefully reset all of the instances in the world so that you can see where they're happening or what they look like without having to wait for them to retrigger. But the problem with that is that it just costs CPU and GPU time, if they are also GPU particles, regardless of whether or not they're on screen. So we can actually show this also in another stat. It is Niagara system counts. These don't autocomplete unless you're playing, so that's a little bit annoying. But we can see that we have 59 of these particle systems, and they're all at NS pebbles. So we can just search here for pebbles, and we can see these are all the pebbles that are active. So we have them really, oh, we even have them outside. So the funny thing is that these are active even though we're not outside at all. Like we're not even near to this, or we weren't near to this. But they're now all actively simulating and doing their thing. Now we don't really see much of the cost with the system counts. This is just to show like, okay, which systems are in the level and how many of the systems are there. We have other stats for that. We have Niagara systems, and this will show us a little bit more already on the cost. So I also like this one because it's also quite simple. It just shows the CPU costs of these. So it has like GT or GT CNC and RT. So game thread that would just run synchronously on the game thread. So that is probably for us the worst one if that would be high. And a GT CNC, that is the concurrency, the concurrent call. So that is game thread related, but it's running on worker threads. And then we have RT, that is the cost that is running on the render thread. And so this is not ideal that these are running, especially if we use our worker threads for a lot of other stuff already. If we want even more detail, then we have also Stat Niagara available. So this will run even more. Maybe by now I should just hide some of the others because it's getting a little bit full. So we can properly see what we have. So this is the most detailed version. And here we can also see GPU dispatch setup. And we can see other GPU costs here as well. And this is very interesting because now we can very clearly see that, and also if you see the GPU memory that's being used, the GPU instance counts. So there's quite a lot of stuff here, which is excellent because we can see that, okay, there's quite a lot of stuff going on with particle systems, but we're not seeing much of this. And that's because there's just no culling by default unless you specifically set this up in your Niagara systems. So let's very quickly go in and find, first of all, find this particle system. I'm just gonna get Niagara system. And also because I already have the content folder, the root folder selected, I can just easily find NS Pebbles. And the problem is going to be here in the system where we don't have an effect type specified. You can also have things specified in the renderers where you can have individual culling and things like that. But I think the very first thing you should apply is an effect type. And as you can see that all of these are GPU based. Now, it's not always necessarily good to have GPU particles whenever you can, especially in a sample like this, we're entirely GPU bound. We're basically doing almost nothing on the CPU. And so it might be better for certain things to just be a CPU particle system rather than a GPU. Now, in this case, I'm not too keen on getting or changing all of this. Also, they have things like collision setup, which is using GPU distance fields. For your particle systems, you should really consider, like, does it actually benefit me to have this be a GPU particle rather than just always trying to have everything be GPU? And that's really a case-by-case basis as always. So we have the NS Pebble. So I'm going to create a new effect type. I can also just create asset here or just use it through the content browser as usual. I think we are actually... I'm going to put this in effects. Yeah, I'm just going to put it in the root folder of the effects. And I'm going to call this ambience effect type. I don't really have a particular convention for this at the moment, but just I want to set this as an ambience effect type. You can make this as specific for a single particle system if you want, but generally speaking, you want to categorize this for a very particular set. Like maybe your muzzle flashes will, in your shooter game, will have one effect type, and maybe the bullets, projectiles will have another one. The impacts might all share one effect type, etc. So let's open that up and do some really basic setup. We don't have to do a lot here. I just want to have the absolute basics. So let's set up a system scalability settings. And if we open that up, we can specify for which of the scalability settings we want to enable this. Now, I'm going to only have one at the moment, but you might want to, for example, set them on high and epic. Cinematic is not super relevant for us, but if you have a cinematic preset, that's of course relevant. And then we can add another one, and then we disable these others. So now we have these settings for the low and medium spec, and then High Epic Cinematic have their own setup thing. But I'm just going to keep this to 1 for now to keep it very flat and simple. So we can set up things like, okay, beyond this distance is going to be called, well, I don't really want to have a distance call because I think seeing them from a really far distance still looks pretty cool. So in this particular example, I'm not going to do that, but I do also not want to have budget scaling. We're not dynamic enough for this scene, but I do want to have, well, also pre-culling. Actually, we don't have that, but I do want to set a max time without render. If we're not rendering for like, I don't know, half a second, just cull us. Just stop rendering us entirely. And then the allow pre-culling by view frustum. This is going to be super relevant for things like gameplay, where the gameplay might spawn the system or might spawn the like a muzzle flash or something like that. And then if we enable this, it will first check the bounds of the system. So you have to make sure you have good bounds. And then it will decide, okay, well, actually we're not visible. We would not be visible right now. And so we just don't even bother spawning it. That's super valuable if you want to have something like a very short-living particle system that if you don't immediately see it, like a muzzle flash, don't even bother instancing it because you're never going to miss it. So we're also just going to enable this. I'm not entirely sure how they spawn this. It's just a regular system, but especially with things like gameplay, we'll be able to pre-call, which is really, really nice. And also max time outside view frustum. Let's again, I don't know, set this to half a second or so. We have other options here, but that's not super interesting for this particular scene. We'll have more detail on that in other videos. So let's save this guy out. Let's make sure this guy is also, it's applied, and we can just apply this. And so finally, before this starts to work, because these are ambient little systems that are already in the scene, having this update frequency be spawn only doesn't really work for us because we're not like a muzzle flash where we're only wanting to maybe check this on the spawn or something, but we want to make sure that we are checking this constantly. Well, we don't necessarily need this to be continuous. Like it doesn't have to be every single frame. Maybe once per second is good enough. And that will say, like here you can see that that's by default, that's 1 second. Every 1 second it checks it. For example, high will be 0.25 seconds, continuous will be every frame. Now that's a bit extreme for our needs, so I'm just gonna set it to low, that's all fine. And now if we go back in, we can see this counts quickly going down back to 2. So now 2 of them are shown here, and actually if we go and then re-enable some of the counts, here we can also see like, yeah, we indeed have only 2 of those pebbles currently active, which is significantly better than the 59 that we had enabled before. And besides this affecting the CPU, these are also GPU particles. Of course, if we are actually rendering them, then it would affect things like translucency. But if we're not rendering them, then it would still be able to affect things like the compute shaders that are running for those GPU-based particles. So if I just quickly do stat none to clear all this out, and then do stat GPU again, and if I were to maybe clear this guy out, let's respawn this, and now we should see, like there we go, Niagara GPU simulation is about 0.1. It can spike sometimes a little bit higher, maybe if we, depending on like how many particle systems are actually active. So if I use shift and I just re-trigger them, then we could see that it does actually spike a little bit higher, like 0.6, actually 0.7, between like even up to almost 1 millisecond. So it does spike up and down a little bit based on how many of those systems are currently simulating, colliding, and everything like that. So certainly having this effect type set up for this ambiance is going to be very, very helpful, because now we should be able to probably not even see this anymore. Ah, there we go. Actually, I can see it here. So it's 0.02 by just setting up this little effect type that took us a few minutes. And you want to make sure you enable this essentially on every single particle system, well, in your game, but also in your environments. So fires, just ambient little candles, if they happen to be particle systems. In this sample, they are not. They're actually just simple animated planes. So that's another nice step to improve performance in this example. So then let's have a look at some particular assets, actually, because I happen to just find issues with assets by just sometimes opening the first asset that I would see, I would open it and would immediately see an issue. So let's actually go in, rather than me knowing which assets are problematic. Let me show you how well, some of them I just stumbled on luck with some luck, but others I used some tools. So let's just use the tools. And actually I used, let's see, audits, and then we have the statistics panel. I still like this. This is a really old tool, but it still can be helpful sometimes to find out what's going on in your level. So here we have the primitive stats enabled. And sometimes I like to just look at individual things, like maybe, what do we only have one instance count of? Like, do we need this asset to exist at all? Because if you only use it once and it's not a hero asset, it's not an important thing at all, maybe if we just delete it from this level, it doesn't even get used in our game anymore. And now we don't have to package that asset, the static mesh, we don't have to package maybe even the material or its textures. So this can really trim down on assets. It can be a bit of a annoying thing to, you know, go through all the assets, but it can pay off if you apply this pretty broadly to your level. Now, these things are mostly going to be like pretty unique meshes. Okay, so we have these columns. For example, we have the armor. Well, that's certainly going to be one-off because we only have this one skeleton mesh, but we still really want the skeleton mesh. But you can really see this and really see, like, okay, there's quite a few that have one instance or maybe only two. It is a thing you could consider for your game to really optimize things. And it's going to actually affect a few things. So it's not going to only affect your packaging sizes, which is still very important, of course, because why do we have so many games that are 100 gigabytes plus? It's just that a lot of stuff gets stuffed in there with poor consideration for the end user. The other thing that it might affect, especially if there's unique materials on these, is that we do, in a way, increase the nanite draw calls. Now, nanite is getting extremely good at, has always been really good at draw calls because it does instancing so well. But if we enable something like nanite stats, actually, I'll have to make this a little smaller. We have these shading bins over here, and we have 277 shading bins. So that's essentially 277 draw calls, and 213 of those are empty. That means they were sent to the GPU, but they didn't do anything. Now, I believe in recent versions, maybe 5.4 or so, it's going more and more towards compute shaders for also these shading bins, which means that there's less waste. They can be pruned much more easily. So there's less overhead to having a lot of these empty draw calls, essentially. Earlier versions, that was a little bit worse. You had to be more considerate, but still, I would say, like, probably good to be considerate about this. And now if we just zoom, like, look around, we have the same amount of draw calls, but we have fewer empty draw calls. We're actually using more unique materials. And if we were to just grab this one guy and delete it, we go down one draw call because there was a unique material on this guy. So that's another thing, that if you were to remove a bunch of these unique assets, essentially your draw call count is going down regardless of whether or not they are on screen. Now, it really depends. Your mileage may vary whether or not this is going to have any impact on your scene. But just a little bit of a shout out to shading bins and the number of unique draw calls that you will be generating, especially if you're using things like material instance dynamics a lot. This could really balloon to thousands, which is not ideal, especially because we really don't need material instance dynamics anymore. We have better solutions for that, such as custom primitive data, which doesn't require unique materials. Then let's have just another look at some other things that I always find interesting. There's also some like light map stuff here. This is not super interesting anymore. And also this UI is not always the best to resize, but we have, well, triangles. Sure, we have also instance counts. It's nice to see like how well we're instancing certain things, but really the size is interesting because if we just look this up, well, actually, okay, so the size of these vines is kind of crazy. I was not expecting that, so let's have a look at this. First of all, I see that these guys are about 1 million triangles, and for some reason, nanite is not enabled. So this is going to be a bit of a nightmare for a lot of things, including Lumen performance, but also for, well, shadow performance, if these guys are shadowed at all, if non-nanite virtual shadow maps is enabled, then that's going to be a disaster. But we can just click on this little, the three actors to actually see where they are being used. Actually, that's just up top the stairs where we just were. We were just in a room right there. And so they're just right here up the stairs. So for some reason, these guys are non-nanite. Now, I don't know why. Probably just a bug, I imagine. Just an oversight. Okay, enable nanite support really should be the first thing we do. With this ridiculous number of triangles, I think it's going to be a bad time not having nanite enabled. And then for things like Lumen and virtual shadow maps, it's going to be really bad. So let's just apply this. And now we can see, okay, well, at least our fallback triangles are now like nice and small. Those fallback triangles are used for a number of things, including things like hardware ray tracing for Lumen and also for collision generation. Now, realistically, this really doesn't need collision, but again, Unreal has everything just enabled by default. So yes, it will have collision. That's also why this was just so absurdly large, because the collision data was really massive. So if we just refresh this now, it's gone, right? It disappeared. So if we just search now for Vine, we can see, okay, actually, the size is now 1.2 megabytes instead of something like, what was it, 90 or something? I'd already forgot, but it was way too much. So like a complete utter waste of resources. And it was just because Nana was not enabled. Now, actually, if you're curious to see, also easily just browse your level and see when things are not nanite. I actually like to do the following. I'm just gonna disable it again. And we have the show flag dot nanite meshes. And if I just disable this, now actually you can just very crudely go through your level and see like, okay, actually, so selecting does still use the original scene, but so you might sometimes have to fly up really close to be able to select it because the other stuff might still be in front, even though it's not rendered. But then we can see, okay, actually, yeah, these vines are not enabled. Also, these other ropes are not enabled. That's also one. Of course, there's other ways to go about this. You know, we have a whole view mode available for this. Let's see, mask. So this will also show it for us. But, you know, if there's something behind this wall, you would not see that it wasn't not nanite, right? So this alternative, let's say, hacky approach can also be very useful, that if you just hide your nanite meshes, it will more easily maybe show that your level should be mostly empty. But yeah, the mask view mode is also useful. Okay, let's re-enable these guys. Oops, let's re-enable. Now there's more we could do with this asset, especially regarding collision, but I think this whole level needs a collision pass, honestly, because there's like just a lot of memory wasted on collision. But since this is not a gameplay based map, this is purely a visuals map, I don't think they really cared about it all that much. But since people are going to extract meshes from this and to use in their own game, their own scenes, I feel like they should have cared about this. Anyway, let's move on and let's have a look at the second biggest, which is now the biggest, and that is actually this helmet. And let's actually select it in the world. That is more interesting. Now this is gonna have, I mean, it looks really cool, and they have like a pretty far near clipping plane, by the way. Just a little bit annoying to see, but we can just hold down right mouse button and just press C to like really zoom in. So we can see this, all this incredible detail. It looks really freaking awesome. But again, there's something up with this because 66 megabytes is way too big. While we're at it, by the way, I just want to hide my nanite stats. Nanite show stats 0. In case you don't know, like using a space in your console commands makes it so much easier to find your commands, right? If I had to remember that there was like r.nanite.show stats, I would just constantly forget exactly what it was. So just nanite, white space, and then something with stats. You will also see the results. Like maybe this is super obvious for everyone, but I don't know. It's helpful. Okay, so this one is also way too big. Definitely a problem with the asset. So let's double click it and open it. Oops, press F to focus. And also this is a problem because nanite is enabled, but look at the fallback triangles in the top left. We have the, let's see, we have the fallback triangles is 800,000 triangles. That's awful, truly awful. It's the same as the nanite triangles. And also if you're on an earlier version, the 5.2 or anything like that, a lot of these are going to be quite poorly set up, probably. Like not guaranteed, but I'm pretty sure a lot of them were set up poorly. Maybe depending on how you upgraded your assets from like 5.0 to some other version. But if you have a more recent version, you should be fine. But in this case, you can already see that it's not fine because the fallback target is not set to default. It's triangle, it's percent triangles, and that's 100%. That's ridiculous. Okay, so let's set it to auto, which is the current default again. And let's apply the changes. And again, the reason why this is so awful, even if you're not, or even if you're just using Nanite, the fallback triangles, fallback mesh is still very important for, again, for things like collision generation. So something like line traces would have been line tracing against a helmet that is like 800,000 triangles. And we can visualize this also with the visibility collision. So let's see. If you can't really see this well, maybe just, let's hide meshes. So under the show flag, let's hide static meshes. And here we can see still, I find this to be a little bit ridiculous because we never need this level of detail in our collision. So there's a couple of things around this, or a couple of ways around this. And also, I mean, let's have a look at this stuff actually. Like look at these crazy, the crazy detail in all of these wooden planks. Like this should just be a cube, right? It should just be a simple primitive rather than something as crazy as like a highly detailed with all the grooves of the wood. But anyway, let's try to focus on this particular asset, because at least now with this fallback set properly, we have 10,000 triangles to consider. That's already significantly better than what it was before. So we will have now improved both, well, the collision performance in this environment, but also we'll have improved things like the ray tracing cost that will still at this time use things like the fallback mesh, because not everything supports nanite at this time. Okay, so that was a quick, oops. Oh yeah. Oops, right, because we have disabled static meshes, we completely messed it up. Another cool thing that I think is just funny is just if we go into our nanite visualization and we just check out triangles, we can see actually that they modeled out these, all of these spider webs, like cobs, spider cobs, what do you call these things? Cobwebs, yeah, sorry. All these cobwebs are just modeled out, which is pretty cool, and it's gonna, I guess, perform a lot better than something like mask materials when you use nanite. But still, it's I just thought it was interesting because before that we would never really use triangles for something like this. But with nanite, it's all possible. Okay, so let's just do a few other things. If we go back into the stat GPU, I think this is just interesting to continue going down some examples, or just going down some of the costs here. I can see a lens flare is enabled, 0.7 milliseconds, but if I just disable lens flare, and again, if I don't remember the command exactly, I'm just going to type out lens flare, and we see lens flare quality, and then in the output log, I'll see, okay, the current setting is 2. Actually, it was set by scalability, so it is controlled by scalability. I'm not going to be worried about that right now. I'm just going to set it to 0. That's for quality 0. Now we can see the cost is entirely gone. Okay, that's great. But I want to check out quickly if I can find a place where this is going to affect me. So first of all, let's remove stat GPU. I don't care about that right now, but I do want to A/B test to see, am I using this somewhere? I don't know if I'm using lens flares. A/B test, and then we have I do have to remember the command r dot lens flare lens flare quality. Luckily I can read it, and we're gonna be toggling between between 0 and 2. So A/B test r dot lens flare quality 0 2 0 space 2. And now we can see that we're toggling between them. Now, of course, this is just, it's going to give us a performance comparison, which is nice, but that's not really what I'm on about. I want to make sure that I can actually see if I can find the visual difference, if I can see any kind of visual popping. Okay, so yeah, here we can see the difference, right? We can see it popping in and out. But do we really need this? I mean, if we're going to be using this on a lower end platform, if we had it turned off, would we have noticed? That's really the question. Like there's a visual difference, but could we not just maybe scale some other value up a little bit to get this same lighting? Because it's mostly just blur, like makes the whole scene a little bit lighter around where it is showing the brightest spots in the scene. Like really not worth any kind of consideration. That's like 0.7 milliseconds is way too much. Also, we don't have any, we don't have anything with the candles or something that does some kind of crazy lens flare effect. Let's have a look. Yeah, so it really just is sort of making the whole thing a little bit more bright. And then you can consider, do we want to spend that much GPU on this? On a 4080 Super? Like, what if we go to an even lower end device? Now, of course, it's already set up in scalability, right? So if we go down in scalability, probably the cost is already smaller. But yeah, so let's first of all, let's A/B test stop this. So really, we should be able to disable that. And for some reason, I'm now currently FPS locked. I'm not sure what I did or if anything has happened. But just, you know, setting T max FPS to 999, got rid of it for now. I'm not sure why that was suddenly happening because I didn't see that before. Maybe I changed some settings somewhere. I don't know. I think for this video, the final thing I want to just call out, because we're just exploring this scene, is that there's actually a lot more to talk about. I think I'm going to do two more things for now. The first one being the basic setup of light culling and making sure that lights are of a reasonable cost. Now we have mega lights enabled and we have these ridiculous number of lights over here. Now that's already going to be dramatically bad, but there's a couple of things we can just really easily tune here. The first one being just attenuation radius. That's the most obvious one that, you know, honestly still gets done incorrectly all the time. Like for example, we have this, this light got selected. So if we press T, then we disable the translucency selection. So now we have the option to select this light. Now this light is really cool. It's a hero light for sure. But if maybe we can go to wireframe, well, no, we can't because that's lumens, sorry, that's nanites. So it looks impossible to see. I want to just quickly show you just how large this light is really. See, it's really massively bleeding into this other world, this other room. And it has a really large attenuation radius and a really large cone. And so it also goes underground for quite a bit over there. And so the problem is that it's going to add cost even if we're quite far from it. And especially because if we go back to lit mode, if we were to just disable the lights, and for that we can always use affect world, it doesn't really affect this section of the world at all. Well, okay, here it does, right? If we're just back into that room, that's obvious. But here it still has the attenuation radius and it doesn't affect the scene whatsoever. So realistically, if we want to make this perform well on any kind of device, we should realistically just be a little bit more conservative when it comes to, well, attenuation radius. And so I think we can just reduce this one, like we can make it smaller without trying to affect the overall scene too much. Like you're going to really upset artists if you're not the one that plays this light and you're going to be messing with it. But we really have to consider this. And now we can see that on the top here, it's going to be reduced a little bit, but you have to also consider, like, is it really going to be worth the cost, right? Can we afford these lights to be this massively, this large, and affecting us in a much wider area in terms of light projection cost than what we were expecting? Could also affect things like shadowing, but that's a little bit different for virtual shadow maps. That works a little bit different for like non-virtual shadow maps, whether or not things get invalidated or re-rendered, but or get cached. But the bottom line is it's still going to affect our light projection cost, right? That's just going to essentially render the shape of this cone on screen. And so the more our screen is affected by these lights, essentially that's going to affect the cost of the lights. And so we want it to be small, right? And the second thing we want to do is have something like a draw distance enabled on this. Like even with this light in particular, we should be able to set up a draw distance. So let me just make this a little bit more readable again. just gonna type distance, and then we have max draw distance, max fade range. And what I usually would do is try to find the max visible distance for the light. Now here, this is really small, right? We just go around the corner, and so we're already really close. But maybe if we were to view this from this bridge right here, and now I want to deselect this light, but of course we want to be able to tweak it. So I'm just going to use the little lock. So now we can escape. We deselect it. We no longer have that distracting little thing. Also, we can just use game view if we wanted to keep it, but without all the distracting icons. And then let's, well, first of all, let's set a draw distance of 100, where it's definitely got to be turned off, right? Now we can see that this is turned off. It's not, it doesn't look great because we want this to be, you know, this looks better. To be fair, it's not as big of a difference as I was expecting. Maybe we could make these candle lights more pronounced as we're this far away, but that's, you know, more of an artistic thing as well. So let's set this to, let's just find the range like this. Okay, so there we go. We can slide it here. So around this range is when we enable it. Sure. And then of course we never want to pop this in, because if we were to like do this looks awful for obvious reasons. You don't want to have pop in. So we could set like, usually I start with a fade range of 750. It's just a number that I end up using, which looks pretty well, but it really depends on how you're using your lights. See, now it sort of blends in as we fade in and out. Though probably I want this range to be even bigger so that the player can't see it, so that it gets called entirely beyond this range. So then the light, the shadows are going to be called. We don't have any like accidental like invalidations, and we don't have any light projection cost, even if it's on our view, because we just have disabled it. And so let's use some numbers in order to actually check out whether or not this is going to work. But for that, I do, at this time at least, want to disable mega lights, because that's going to be messing with our stats a little bit. And also, again, mega lights is experimental, and just certain stats are going to be different. So I don't really want to use mega lights for this particular little test, whether or not it gets called or not. So I'm just going to disable it. Are the mega lights that allowed? 0. It does have some overflow and has some other issues, again, because this scene is definitely made for mega lights, not for anything else. But with that, and I can just make sure we have the draw distance and set up so that it will fade in and fade out. Mega lights is disabled, and then I want to set up draw count as one way to show you just how many lights we have. Like now we have 124 lights. Also, if we use something like stat GPU, we should be able to see, let's see, lights. There we go. It's actually the number 1 cost right now, the lights. So this is the light projection cost. This is not the shadow casting cost, that's under shadow depths, but the projection of the individual lights would be under here. Now we have 124 lights that we are actively rendering. That's a lot. Now that's maybe a bit too much. Also, it would be less, by the way, if we had mega lights, because I guess the stats just work a lot differently in how it calls lights. Honestly, with mega lights being so new, I'm not too familiar with how it operates. That's why I also just disabled it for this particular test, especially because I doubt people want to use it immediately. So if you just set this back to 0 for a second, now it's definitely enabled. Let's just go back slightly. So we have 116 lights. And now if it definitely call this, we have 115 lights. So we can see that indeed we have this light getting called. And then as we approach it, well, actually a lot of lights go up, but that's just because other lights get visible or started getting projected. And so there's maybe a chance that our light projection cost would go up a little bit or go down a little bit, depending on whether or not we have this light enabled or not. It's probably not going to be a huge difference because we have just this many lights going on. But yeah, with stat draw count, we should be able to see, but with stat draw count, you can see kind of the calls that are being made and whether or not like you have like an excessive number of lights that are currently being projected, which we definitely do. We have now even 180, so 260 lights. So yeah, we have a lot of stuff. We have a lot of these candle lights that are being currently projected. So that's something we should really focus on if we wanted to get good performance out of this. Because we can even see that the light projection cost is significantly higher than even the shadow drawing cost, which you wouldn't really see all that often. And if you do, then you have something to fix. Or you have incredibly well cached shadows. could also be. So the next step would be to set up like the attenuation radius and honestly the attenuation radius and also things like draw distance on these individual, let's see, let's me reselect it. I still had it on lock on these individual lights. And actually this is also set to an attenuation radius of 2. Now, if you set this to like even like 50, I already tried this out a little bit, it won't even show that much of a difference. Maybe a little bit, like maybe 100 or 75. You can really play with this, but it has to be as small as possible. And then the other thing you want is, I mean, do we even really need this many lights in the scene? Like, because they still use other things like these fill lights, right? This is still other stuff that actually uses a very large radius, which you can, again, just, I don't even see the difference. I can see it at the end here in a small little radius, but it's just like a way too large of a radius. And honestly, even with megalights, we shouldn't really let this happen, right? We should have small radius. We only use what you need. The other issue that we'll have, and that is something we could fix in the material with this particular, like, let me just disable stat GPU again. It's really getting in the way. This little light really is required to be rendered for this candle wax to show up properly. If we were to disable the lights, let's say affect world, now it looks cool, of course, but it no longer shows a lit view of the candle wax. So it visually matches whether or not the light would be on, but of course, this is still shown, right? So we would also have to disable this mesh. That's fine, not a big deal. Looks pretty cool, by the way. This whole scene looks amazing. Again, it just has some performance opportunities. So you would hide this. You would hide this guy. Let's see, visible. And then if you just disable the lights, now it is properly disabled. So that looks visually really cool. And it works this way because it's using subsurface scattering. This doesn't always work, and maybe, I don't know, maybe on lower end platforms, you might not want it. You might want to have a cheaper solution because you can actually fake this same thing in a material. We know the object bounds of the candle, and we can sort of have this gradient effect to still have this light fake transmit through the environment. So, and we've done that before. It's not that crazy. Should easily be doable. And you would need that actually, because and also actually the lights, the shadows are really glitching out right now, but I believe that's just because of the one pass projection is overflowing. So we have all of these broken shadows, which is, not really a concern right now. We would have to first optimize these lights to be, these candle lights to be less crazy. So we could spend more time on this maybe another time, I don't know. The other thing you could consider doing is like, especially on like lower end, do you need this many candles? Could you just, could you grab this guy or even this guy that's even like basically already hidden for some reason? I mean, maybe just delete this. This is just not properly aligned anyway. Actually, and so if we want to hide this, then we would go to the engine scalability and it should be under effect. So if we set this to low, well, actually now a lot of things are going to be recompiling, so it has a lot of side effects. But we could in the meantime set up detail mode. Let's set it on, but we could set it on for example, on this particular mesh, or if we want to set it only on the light, we could disable the light based on the scalability. Based on the scalability here. Maybe disable a light, maybe disable the mesh entirely. So we could play more of that maybe in another part, because this is already really long and there's still a lot more to talk about. Then the final thing I want to just remind you of that's also happening is that by default in this particular sample, the tone mapper sharpen is already set to 2, and that's just enabled in the project settings. We can see here project settings. Also, this is really awesome. They can set the history of how it was set. This wasn't available in earlier versions. I think like maybe 5.4 or something introduced it. I don't quite remember. Very helpful, so that you know like what actually caused this console variable to be this value. Well, we also had this, right? We had last set by, we already knew this, but we didn't know the history. So that's very, very nice. So tone mapper sharpen is set to 2, and this is actually a really big deal, because if we just disable this, I'm just gonna get in some like scenic view. I don't know. Let's me just this area. Of course, shadows are messed up because of the megalights not being enabled. Maybe I should just enable that again. Megalights and allowed 1. Okay, so this fixes that issue. Looks a little bit better, but then let's go and set sharpen to 0. Now, I think in a video, in a compressed video, it might not show up, but this is blurry. This is blurry as hell. Like if we were to zoom in on this, it really gets muddy. And it's also in stationary view. So setting this back to 2 has a huge impact on the quality of this environment. So I feel like this one concept variable is really saving this sample from looking fine to looking really excellent. Of course, like it looks good without this concept variable. I don't want it to be too extreme about this, but it's really an important concept variable that I kind of emphasize enough just how important that tone mapper sharpen is for this particular scene to look this excellent. And that is, perhaps you could consider that as an issue. I would probably agree with that because it's a little bit problematic that without sharpening, it looks this blurry. That is what we're at, where we're at right now. So definitely consider this also for your own projects to have the tone mapper sharpen. Maybe 2 could be too high for you. You could also set it to like 1 or I don't know, half maybe. That should still have an influence. Play around with this in your own levels. It can have a fringing effect sometimes on certain meshes, and I think this is mostly due to a particular kind of fog. I would still have to look into this a little bit more on exactly when this can happen and how we could avoid this. But make sure you properly test this, like tone mapper sharpen, but really consider this in your own projects and see whether or not you get good results with that. And again, you can do A/B tests to run that tone mapper sharpen and enable it and disable it and just see how enormous the visual difference is, especially in like this sample, but also probably in your own projects. Okay, then we'll do one more. I want to just show off one more thing, and this is not really a scalability option, or I mean, it's not set as a scalability option by default in Unreal, but I feel like it should, perhaps it should be. Actually, I'm gonna set this back to Epic for now. I don't want to have anything messed up. And that is actually the Nanite max pixels per edge. And that's actually huge. So max pixels per edge is by default, oops, that doesn't show properly. Max pixels per edge is set to default by 1 or at 1. And that's of course the most excellent view of Nanite. It looks absolutely incredible. This is what we would want. But if you have a particularly expensive vis buffer, or you're just on lower end hardware and your GPU can't keep up, there is the option to maybe reduce this a little bit. And I'm gonna set it to 10. Like this is relatively extreme. And this is really gonna affect the scene. Now, I don't know if we can really properly see it. Let me just toggle. And I think you should look really at the ground pebbles in the middle of the screen to go between 10 and 1, where you can see a little bit of detail being added back in. Also, with this, the law transitions might not be as buttery smooth. So if I set this to 10 again, now if we were to zoom in on this particular mesh, we can actually see the geometry sort of blending in. Like now, this detail, this super detail, doesn't even exist. I'm not sure if you can see that in the video again, because it's just going to be so small. But if we just zoom in, the detail sort of appears. So it's like much more aggressive in the lotting, essentially. But let's have a look. Let's see if we can do a bit of a comparison in the performance. Now we have Nanite vis buffer of 1.8 or so. And now the Nanite vis buffer is, let's see, 2.3. That's 2.2, 2.3. So there is a bit of a difference here. And this is just some view, some scene. It's pretty detailed scene, to be fair, but maybe also like on lower spec machines you might see a bigger difference. And depending on, of course, it also was setting it to 10, which is maybe a bit too high. Even like 2 or 4 or maybe 6 could be useful to scale down. Now again, by default it's not set as a scalability setting, so you can't just put this in your scalability groups and just be done with it. You have to manually set this. But again, it might be very useful for you because it can really reduce the vis buffer cost. And if you do it more sparingly, maybe let's set it to 4. you might not even notice it. Like once you're playing, you might not see that it's actually set to 4. And then now we have it set to 4 and it's below 2. Like mostly it's below 2. So that's great. And actually to visualize this difference, to see, we can either use clusters or triangles. I'm just going to use clusters because that's going to be more easily to see in a compressed video. I'm going to toggle between 4 and 1. We can see that there's just significantly more detail. Like now, even at 10, some are not even colored properly anymore. Maybe this also tells us that we've gone too far. I don't know. But you can see just the number of clusters, and the number of clusters really influences the cost, the performance and cost of native vis buffer, among other things. But clusters is really like a very easy way that you can tell, like, okay, we might have a performance issue if we have like a ridiculous number of clusters on screen. Let's go back to lit. So yeah, there's 1,000 more things to talk about in just this sample alone. But I think this would be a decent starting point of just having done some optimization. Now, we've done this very, very locally, and not everything is applied. Like, lens flare is back on, right? So most of our optimizations haven't been applied in this final moment of the video. So we didn't really move the needle all that much because, a lot of these things are just reset to the defaults. But this can really move the needle on your project. And I would like to maybe see if we can continue this video with more videos that we can really nail down performance, and eventually maybe, and honestly, I don't know at this point if this is going to even run on a Steam Deck, but maybe we could get this to run on a Steam Deck, see just how far do we need to scale down to get this to look decent and run at 60 frames per second. So that's it for now. I think we covered quite a few things. It wasn't super coherent, perhaps. It was just me going through the scene, but there's just a lot to talk about when it comes to this environment. I mean, it's just, I don't know, there's 1,000 things. I could just select these fog planes here, and if we drag them up, we can see like, okay, this is crazy. Like, why does it have so little coverage on such a mega plane of translucency? We'll end up with a lot of overdraw on translucent meshes. So, just selected one more asset and we have another problem, right? So there's a lot of other stuff. So there's a lot of other stuff that we could improve on, but I think this is a good start for today.